Hello students, in the previous session we discussed how to construct the LR0 canonical items and how to construct the parse table. In this session we are going to discuss how a LR0 parsing can be performed. In the LR0 parsing process we are going to use a stack data structure and we have to use two operations already we discussed as push and pop. Of course, they are named as shift and reduce. Then we are going to load the input string onto the buffer, and when we are going to perform the shift operation, we have to increment the look ahead pointer, and if we are going to perform a reduce operation, no need to increment the look ahead pointer. And so, when we are going to perform the reduce operation, we are not going to reduce the current symbol, but the previous symbol. And we are going to perform the reduce operation depend upon the final item. If there is a final item, so depend upon the grammar rule, we are going to perform the reduction operation. So, now we are going to perform the parsing process. So, there are total 7 number of states named as I0, I1, I2 to I6, okay, and where this is the I1 which is consist of final item, seems to be consist of final item, but it is not actually final item because it is the augmented production which is added by us. So, now we are going to perform the parsing. In the parsing process, we are going to use the stack data structure as we discussed. So, this is the stack data structure and we are going to load the initial state number into this stack. Here in the given canonical items, I0 is the initial stack number. So, I have to write 0 in this stack. Okay. Then this is my given input string and initially my lookout pointer is point to the symbol A. So, I have to look what is 0 on A, that means I have to check for from I0 state on small a what is the operation. So, when I am going to check what is I0 on A, I0 on A is S3, that means it is a shift operation. So, I have to place clear. So, this is my lookout pointer is pointing A now. So, I have to write A here and 0 on A is S3, that means it is a shift operation. So, I have to write 3 here. Then when there is a shift operation is performed, immediately I have to improve or I have to increment my look ahead pointer. So, now my look ahead point is pointing to the second A. Okay. Then now I have to write A here. Now check what is 3 on A. Now go for I3. Okay, I3 on A is S3. So again I am going to perform the shift operation. So again write 3 here because here it is the operation is S3. So I have to write 3 here. Now this is a shift operation is performed. So I have to increment my look ahead pointer. I have to increment my look ahead pointer. Now check what is 3 on B. I have to check what is 3 on B. Now check I3 on B is, you can see S4 here. That means it is again a shift operation. So I have to write B on the stack and 4 on the stack because I3 on B is S4, which is indicating that it is a shift operation. So I have to write 4 here. Again this is a shift operation. So again I have to increment my look ahead pointer. So now my look ahead pointer is pointing to the symbol B. Now check what is 4 on B. Always I am going to deal with the top of the stack only. Here the top of the stack equal to 4. So 4 on B I have to check. Now go to the parse table and check what is 4 on B. So now 4 on B is, you can see here R3. R3 means it is a reduce operation. R means reduce operation. S means shift operation. So here it is R3. What is the meaning of R3? That means now I have to perform the reduce operation, but depend upon the production number 3 in the given grammar. So, in the given grammar, what is the production number 3? So, this is the first production, this is the second production, this is the third production. So, the production number 3 is A tends to B. So, I have to use A tends to B dot to perform the reduction operation. Is it clear? Depend upon the top of the stack 4 and the lookout pointer symbol B, I am going to perform the reduce operation because 4 on B is R3. That means I have to perform a reduction operation depend upon the production number 3. So, the production number 3 is A tends to B. Okay? So, it is indicating that I have to perform reduction operation, the B is going to be reduced into capital A. And already we mentioned that we are not going to perform the reduction operation on the current symbol but the before symbol. So, now I am going to reduce the before symbol into capital A. Okay? Then after performing the reduction operation, now we have to do one more operation. What is that? From this production, check how many symbols are existed on this right hand side. How many symbols are existed on the right hand side? You can see B the only one symbol which is existed on the right hand side. If in a production, let us say A tends to alpha, if alpha consists of X symbols, then we have to reduce 2X symbols from the stack. We have to reduce the 2X symbols from the stack. After reducing the 2X symbols from the stack, that means after pop the 2X symbols from the stack, we have to push the left hand side symbol onto the stack. Is it clear? First we have to pop the 2X symbols from the stack and I have to push the capital A, that means left hand side symbol onto the stack. Here the X is the total number of symbols on right hand side of the production. So, what I have to do? Here I am going to perform the pop operation. So, B is reduced to A and I am using the production A tends to B. So, on right hand side there is only one symbol is there. So, 2X means 2 into 1. So, it is 2 symbols. So, I have to perform pop operation for 2 symbols. After that, as per the rule, I have to push the left hand side non-terminal onto the stack. The left hand side non-terminal onto the stack. So, I am writing capital A here. Okay. So, I am writing the capital A. Now, look what is 3 on capital A. Now, go to the table and check what is 3 on capital A. I3 on capital A is, you can see it is 6. So, push 6 onto the stack. 6 onto the stack. Fine. Now, the top of the stack equal to 6. The input pointer is B. You can clearly observe that we are not going to increment the input pointer. Why? Because now we perform the reduce operation only, not the push operation, not the shift operation. So, we are not going to increment the lookout pointer. Okay. So, now the top of the stack equal to 6 and the input pointer is B. So, now check what is 6 on B. So, you can go from the canonical item set or from the table. So, I6 on B is, there is a reduce operation again. So, I6 on B is R2. If it is R2, that means I have to perform the reduction operation depend upon the production number 2 in the given grammar. What is the production number 2 in the given grammar? A tends to small a capital A. So, this is the production I have to use to perform the reduction operation now. Okay. So, now I have to find AA. This is my handle. I have to reduce this AA to capital A now. So, now come to here. So, you can see AA. So, A and A is reduced to capital A. Is it clear? AA is reduced to capital A. And again I have to apply the rule now. What is the rule? So, if this is the production I am going to use for reduction. So, on right hand side there are 2 symbols are there. So, I have to pop the 2 into 2, that equal to 4 symbols from the stack. After that, I have to push the left hand side non-terminal A onto the stack. So, now I have to perform pop operation for 4 times. So, 1, 2, 3, 4. So, this is the second time I perform the pop operation. So, these are the first time we perform the pop operation. Okay. So, after this I have to push this particular non-terminal onto the stack. So, it is capital A. Okay. So, I perform the push operation or shift operation again as capital A. Again, here also I am not going to increment the locate pointer. Why? Because here also we perform the reduction operation only. So, now look, what is 3 on capital A? You find this from this table or canonical item set. Or what is 3 on A? 3 on A is again 6. So, push 6 onto the stack. I am going to push 6 onto the stack. Fine. Okay. Then the input pointer is B only. The input pointer is B only. So, what is 6 on B? You can find 6 on B is R2. Again, I have to perform the reduction operation depend upon the production number 2 in the given grammar. So, A tends to AA is the production number 2. So, again I have to use this production to perform the reduction operation. So, what I have to do? I have to pop the 4 symbols from the stack and push capital A onto the stack and perform the reduction operation here as capital A. Okay. And as we discussed, we have to perform the reduction operation as I have to reduce 4 symbols from the stack. So, this is the first symbol, second symbol, come to here, third symbol and fourth symbol. Okay. I reduced the fourth symbol from the stack and I have to push the capital A onto the stack like this. Okay. So, now check, this is capital A. So, if you go like this, 0 is there. So, what is 0 on capital A? You can find 0 on capital A is 2. So, I have to write 2 here. Now, what is the input pointer? B. What is 2 on B? Check 2 on B from the parts table. So, 2 on B is, you can find S4. Okay. So, I have to perform shift operation. So, shift the B into the stack and write 4 here. Now, increment the input pointer which is a $. Okay. Now, 4 is pointing 4 is the top of the stack and $. Is the locate pointer. So, what is 4 on $? You can find 4 on $. Is R3. 4 on $. is R3. So, again I have to perform the reduction operation depend upon this production number 3. So, this B is reduced to capital A and I have to perform the pop operation. So, here B is 1. So, only one symbol on the right hand side. So, I have to perform the pop operation for 2 times. So, this is my pop operation. After that, I have to push this A symbol onto the given stack. Okay. Now, what is 2 on capital A? Check, 2 on capital A is 5. 2 on capital A is 5. So, push 5 onto the stack. Okay. So, here I am writing the stacks, 5 onto the stack. What is the top of the stack now? 5. What is the input pointer? $. So, what is 5 on $? So, you can find 5 on $. Is R1. That means, I am going to perform the reduction operation depend upon the production number 1 as S tends to AA. Okay. So, what I am going to perform? I am going to perform the reduction operation as S tends to AA. So, this is the parse tree. Okay. And at the same time, there are 2 symbols on the right hand side of the reduction production. So, I have to pop 4 symbols from the stack. And after that, I have to insert or I have to shift the, I have to push the S onto the stack. Okay. So, what is remained? only 0 is remained and S is remained. So, what is 0 on capital S? 0 on capital S equal to 1. So, push 1 onto the stack. Okay. Now, the top of the stack equal to 1, the input symbol is dollar. That means the locator is pointing to the dollar now, top of the stack equal to 1. So, check now what is 1 on dollar. 1 on dollar is, it is accepting. So, in the previous session we discussed what is the use of the augmented production. So, as we discussed, it indicates the parser wait to stop the parsing process. So, here 1 on dollar is accept. That means the parsing is completed, the string is accepted by the parse tree or the machine. So, what I have to write? So, when 1 on dollar is coming, so I have to write parsing is completed. Okay. So, in this session we discuss what are the various terminology we are used in the LR0 parsing, what are the various operations we use for performing the LR0 parsing, and what is the LR parsing process. In the LR parsing process, we use the data structure stack and perform the shift and reduce operations. While performing the shift operation only, we are incrementing the locate pointer. While performing the reduction operation, we are not going to increment the locate pointer, and we are not going to reduce the current symbol, but the before symbol depend upon the given productions in the grammar.